Good morning. Today, in this session, let us learn about intermediate code generation in the phases of compilation. During the first phase of compilation, the given input statement is scanned from left to right and checked for lexical errors. That is, whether all the characters of the statement belong to the language or not. During the second phase of compilation, that is, in parsing, the given statement is checked against the grammar of the language and uh, syntax errors are identified. This syntax tree, which is the output of parsing, is given as input to the third phase, that is semantic analysis phase. In the semantic analysis phase, type checking plays the major role, adding meaning to the statement. That is, checking for the type of variables and uh, including syntax directed definitions are the major tasks in semantic analysis phase. So the output of semantic analysis phase is to be given as input to the back end of the compiler. So the front end phases were lexical analysis, syntax analysis, and semantic analysis. The annotated parse tree, which has the attributes of all the grammar symbols, and syntax directed translation rules are to be given as input to the back end of the compiler. Before giving this input to the back end of the compiler, this annotated parse tree is converted into intermediate code. So the intermediate code generation is the phase in between the front end and the back end of the compiler. The front end translates the source program into intermediate representation from which the back end generates the target code. What are the benefits of this intermediate codes? Retargeting is facilitated, which means the front end of the compiler can be attached to any type of backend, which is machine dependent. So the front end of the compiler can be attached to uh, any type of processes in which the compiler can be used. So compiler for a different machine can be created. Compiler for a different processor can be created by attaching this front end, this intermediate code to the existing backend. Similarly, machine independent code optimization is another advantage in using intermediate codes. What are the ways of representing these intermediate languages? There are three main ways. One is syntax tree, postfix notation, and three address code. We all are familiar with syntax tree and postfix notation. We know that the abstract syntax tree is the output of parsing. And in our data structures, we all know to write the postfix representation for any expression. So let us see an example. of syntax tree. So this syntax tree depicts the hierarchical structure of source program, and the different form of syntax tree is directed acyclic graph. The improved version of syntax tree, or we can say a simpler version of syntax tree, is directed acyclic graph. Here, if there are any common expressions, they are not written, they are not represented many times. Instead, they are represented only once. So, this is the difference in directed acyclic graph. Let us see an example for this statement: A equal to B into minus C plus B into minus C. So, we shall draw the syntax tree. So, we are given first B into minus C. So, we can write B into, then you have to make C as minus before multiplying. So B and C are at the leaf level, and for minus only C is the child. For star, B and minus C are the children. So this is how we will draw the syntax tree. Similarly, there is one more B into minus C, so we can write the similar way: B into and minus C. So this is to be added. So plus will have these two trees as children. Now this is to be assigned to A. So A is one child for which the parent is equal to. So for the parent equal to, A and this computed result will be as children. So in this way, we draw the syntax tree: B first, then minus C has to be taken, and this should be multiplied here. This should be multiplied here. Then we have to multiply B into minus C here, and finally this should be added, and then this will be assigned to A. So this shows the evaluation order, the dependency graph. The change that we should make with the directed acyclic graph is B into minus C is drawn only once, and here in the syntax tree, the left child and right child are shown independently. Instead, it is shown only once, and the left child as well as the right child will be the same, and it is combined by plus. This is the only change with the directed acyclic graph. The common sub-expressions are represented only once, and it is assigned to A. The another example for intermediate code is postfix notation. So we all know that postfix notation has the operator after the children. So here nodes of the tree in which node appears immediately after its children. So when we have B into minus C, so this star will appear only after the children B and minus C. So, and for C, minus is the parent. So minus will appear only after C. In that case, C and then minus. Then the children are B and C for star. So star will appear only after B and C. Similarly, we have one more B and C, B, C star minus star. Then only after these two children plus sign appears. Only after these are all children for equal to. So for equal to, A is another child, and then plus sign and equal to will be the last thing. So you will be having A is left child and all these are right child, and finally you will be having the equal to sign. So this is how we represent in the postfix notation. The next type is three address code. Before getting into three address code, the different ways of representing syntax tree is with the node diagram. So in this node diagram, we represent the left pointer and right pointer explicitly. So when we have the assignment symbol, we have left child as well as right child. Left child was going to A and right child was given to plus. And then again this plus had left child and right child. The one left child was star, another left child was star. So this is how we draw the syntax tree. And then for star, B was one left child and right child was minus sign. For minus sign, the left child was C. This is how we can draw the syntax tree. And the variation in this pattern is denoting the evaluation order. So we did first only B. In the previous place, we did only B. So here this was given first, and then uh, for multiplying we need both C and minus. So next we did only C and it was made as minus C, then only we multiplied. So this order, so 0 takes up the first place and B takes up the first place and C takes up the first place, and then after that minus sign, only after that star. Okay, then similarly here B takes up the fourth position, C the fifth position, minus the sixth position, plus is 7. So in order to compute plus, 3 and 7 should be available. So it is 8. In order to assign, we need A and the result. So we have to have 9 as A and then equal to should be as 10. So now this uh, will be represented in the syntax tree. That is, 3's left child will be 0 and 2. 2's left child will be 1. 7's left child will be 4, right child will be 6. 8th left child will be 3 and right child will be 7. So now look at the table. 0 is B, 1 is C, and then 2 is unary minus, for which the left child is 1. Okay, and for star, the left child is 0 and right child is 2. So this is how it is represented. One of these ways can be used to represent the syntax tree. So next thing is about three address code. Three address code is a sequence of statement of the form x equal to y operator z. So in simpler form, it has only three operands or three symbols or three variables or three addresses. That's why it is called as three address code. It usually contains only three addresses x, y and z, and OP is any operator. It can be addition, subtraction, multiplication, division, less than, greater than, relational operators, logical operators, and or not anything. So for example, if there is a statement as x plus y into z, x plus y into z. So first we can multiply only y and z. If we do all the three at a stretch, we can then it has more than one operator, star as well as plus. So that is not possible. So we have to multiply y into z, and then the result must be stored in a temporary variable t1. So this result is available as t1. Now x can be added with t1. So x plus t1 is stored to t2. Therefore, this T1 and T2 are called as compiler generated temporary names. So this is the representation, 3 address code representation for this simple expression x plus y into z. So similarly, let us do it for the given example. So we were given here a into, sorry, a, one second, b into minus c, a equal to b into minus c plus b into minus c. So at a time we can use only one operator. So we have to do first for this minus operator. So we can write it as t1 equal to minus c. t1 equal to minus c. Then this t1 should be multiplied after b. Therefore, b into t1. So it is written as b into t1. The result can be stored in t2. Similarly, for this minus c, again one more temporary variable can be used, t3 equal to minus c. Now this again can be multiplied with b. So b into t3 is assigned to t4. Now these two should be added. The previous result was in T2, now in T4. So T2 plus T4 can be added and assigned to T5. Now this final result T5 can be assigned to A. This is the way we can represent the 3 address code for the given expression. Now similarly we can write for DAG. So when we write for DAG again, T1 is equal to minus C. Then we have to multiply this result with B. Therefore, B into T1 will be as T2. Now, another expression, this is going to be the common expression which is repeated. Therefore, we can add T2 itself 2 times. So, instead of redoing, it will be done as T2 plus T2. So this result can be stored in a variable T3. Now this result T3 can be given to A. So in this example, they have made it as T5 and they have shown that's all. So this is the way we can write the 3 address code. One thing what we noted is in the syntax tree, it was a lengthy set of expressions. Now it is a optimized code. So the advantage of intermediate code is it can be optimized in a machine independent manner. So that is one of the advantage. And second thing is any complicated expressions can be represented in a simpler form. That is one thing. Second thing, once it is represented in intermediate code, rearranging for postfix notation will also be easier. Now, the different types of 3 address statements for programming statements. We may have assignment statement, copy statement, flow of control statements, jumps, and procedure calls. So let us see how to give the 3 address representation for these various types of statements in program. So any assignment statement can be given as x is equal to y X is equal to Y operator Z. Any assignment has got only now three variables and one operator. Any simple unary minus statement can be given as X equal to operator Y. X is equal to minus Y. Anything. So it can be given as X equal to operator Y. Any copy statement can be given as X equal to Y. So because maximum only two variables are used and only one operator is used. Then unconditional jumps can be given as go to statement. Go to and to the uh, uh, label to which label of statement to which the control is being transferred to. So go to that label can be a constant, a number, or again an identifier. So only one identifier is given. Then conditional jumps like if x greater than y. So it can be given as if x relational operator y go to label. So altogether only three variables x, y and l are being used and only one operator, relational operator is being used. And procedures. For example, we have a call for the procedure P of x1, x2, x3. For example, factorial of number, fact of n, or merge sort of n, array of values and number of items. So any procedure name P followed by its parameters. So it can be given as all these parameters are to be defined separately. Param x1, param x2, like that. With the keyword param, it is denoted, and then the procedure call is given by the keyword call. Call procedure name followed by number of parameters. So in this way, any procedure call can be represented in three-address code. And suppose if we have array-based statements, indexed assignments can be given as the array can be in the right hand side, array variable can be in the right hand side as well as in the left hand side. So y of I can be assigned to x as x equal to y of I, and similarly y could be assigned to an array variable x of I equal to y. Similarly, pointer variables also can be used in programming statements. So, pointer based assignments could be the address of the variable ampersand y can be assigned to x. So, here again, uh, it is something like x equal to minus c. Okay, so the assignment operator in the right hand side we have only the one operator which is address operator. And then suppose if we want to store the value of point variable y, then we can give x equal to star y. Then if we want to assign a value y to a pointer variable, then we can give it as star x is equal to y. So in these 8 ways, any programming statement can be represented in three address code. Thank you.